Hello everyone. Today I am going to present my CIS 285 term project, which is based on UML modeling for a software system called Split Smart. This project focuses on designing a system that helps users manage shared expenses in an organized way. In this presentation, I will explain the overall purpose of the system, its requirements, and the UML diagrams I created, including the class diagram, sequence diagrams, and state diagrams. These diagrams help show both the structure and behavior of the system. A system overview. SplitSmart is a software system designed to manage shared expenses among multiple users. And the main purpose of this system is to help users track, divide, and settle expenses in a structured and organized way. This kind of system is helpful in many real life situations. For example, it can be used by friends sharing bills, roommates living together, family members, or even people going on a group trip. Instead of calculating everything manually, the system reduces confusion and helps make sure the expense calculations are accurate. So, overall, Split Smart makes shared expense management simpler, faster, and clearer for users. Key features of the system. This slide explains the key features of the Split Smart system. This first feature is user account management, which is handled by the user class. This allows each user to have their own account and authentication information. The second feature is a group creation, which is handled by the group manager. This allows users to create groups and manage groups members. The third feature is expense sharing, which is handled by the expense manager. This part of the system processes expense details and manages expense related operations. The fourth feature is the notification system, which is handled by the notification service. This sends updates to users whether important action happen in the system. These features work together to support the main purpose of the system. Now I will explain the functional requirements of the system. Functional requirements describe what the system must be able to do. In Split Smart, users can create expenses by entering details such as amount, date, and description, etc. So they can also edit expenses if a correction is needed, and they can delete expenses when necessary. Another important function is viewing expenses, which allows users to see expenses they created or participated in. The system also supports splitting expenses equally or by percentage, depending on the situation. Users can add participants to an expense, and the system automatically calculates each user's share. Finally, the system sends notifications when new expenses are created. Yeah, so these requirements are important because they define the main operations that the system must support. Now, this slide is very important because it explains how the system actually works step by step. First, the user logs into the system using their account. After logging in, the user can create a group or join an existing group. Once inside a group, the user can add expenses by entering details like amount and description. The system then processes this information and calculates how much each user needs to pay. If the system requires approval, the expense is sent to another user or group for review. After approval, the expense becomes part of the final calculation and users can settle payments. This flow represents the real life use case of the system. It is very important because it connects directly to the class diagram. For example, user actions are handled by user manager. Expense operations are handled by expense manager. Group actions are handled by group manager. So this slide shows the logical connection between user actions and system processing, which is implemented using classes in the class diagram. In addition to functional requirements, the system also has non-functional requirements. These requirements describe the quality and performance of the system. First, the system should have a fast response time, meaning it should respond in less than 2 seconds. Second, it should have high accuracy, so all calculations must be correct and error-free. Third, the system should have good availability, meaning it should be available 24 hours a day within minimal downtime. It should also provide strong performance, so it can work smoothly even when many users are using it. Another requirement is usability, which means the interface should be simple and easy to use. The system must also be reliable, so it should work without crashes or failures. Finally, it must provide security because user data and expense information must be protected. These non-functional requirements are important because they make the system dependable in real use. Class diagram overview. Now I will begin the class diagram section. The class diagram represents the structure of the system. It shows the classes used in the system along with their attributes, methods, and relationships. The classes were identified based on the system requirements, so each class has a specific purpose in the design. Yeah, so this diagram is important because it helps us understand how the components of the system are organized and how they interact with each other. In other words, the class diagram provides the static view of the system structure. System requirements. The slide explains the system from the class diagram perspective. The system includes important classes such as user, expense, and group to manage system data. Users can create accounts, log in, and interact with the system. Expenses are created, updated, and managed through the expense manager, while groups are handled by the group manager. The system also validates and processes expenses before approval, which helps ensure correctness. In addition, payment and report classes handle transactions and summaries, and notification service sends alerts for important actions. So this slide connects the requirements of the system with the actual classes used in the design. Here, I am showing the main classes of the system. There are three types: entity, control, and boundary classes. Entity classes store data like user, expense, and group. And then control classes handle the system logic like managing users and expenses. And boundary classes represent the user interface where users interact with the system. So together, these classes help organize the system clearly and efficiently. Now in this slide, I am explaining the entity classes of the system. Entity classes are very important because they represent the main data of the system. They store all the essential information that the system needs to work properly. First, we have the user class. This class stores user-related information such as name, email, and login details. It helps identify each user and also supports authentication in the system. Next is the expense class. This class stores all expense-related data like amount, data, and description. It also keeps track of who created the expense and what its current status is, such as pending or approved. Then we have the group class. This class manages group related information. including group members and shared activities. It allows users to organize and manage expenses within a group environment. After that, we have the payment class. This class records transactions between users. It helps track who paid, how much was paid, and how the balance is settled among users. And finally, we have the report class. This class is used to generate summaries of expenses. It provides an overview of spending and helps users clearly understand their financial status and balances. So overall, entity classes are responsible for storing managing all the core data in the system, which is essential for the system functionality. Now in this slide, I am explaining the control and boundary classes of the system. First, let's talk about control classes. Control classes are responsible for handling the main logic of the system. They process data and control how different parts of the system interact. The first control class is user manager. This class handles user-related operations such as login and validation. It ensures that only authorized user can access the system, which improves security. Next is group manager. This class manages group-related operations like creating groups and handling members. It controls editing, removing, and organizing users within groups. Then we have expense manager. This class controls expense processing and calculations. It manages creating expenses, splitting costs among users, and calculating balances. Now moving to boundary classes. Boundary classes represent the user interface and allow users to interact with the system. The first boundary class is login UI. This class manages the login interface where users enter their credentials and access the system securely. The second boundary class is add expense UI. This class handles the input for adding new expenses. It provides a user-friendly interface where users can enter expense details easily. So overall, control classes handle the system logic where boundary classes manage user interaction. Together with entity classes, they create a complete and well-structured system. This slide shows how different classes are connected and interact with each other. The user class interact with both expense and group classes. The expense manager handles all expense related operations such as creating, updating, and validating expenses. The group manager manages group creation, invitations, and members. The user manager handles login and validation of users. These relationships are important because they show how the system flow is implemented using the class diagram. For example, when a user adds an expense, the request goes from the user to the add expense UI, then to the expense manager, and finally to the expense class where the data is stored. So this clearly shows the connection between system flow and class diagram. Each interaction in the system follows these relationships, which ensures that the system works correctly and efficiently. Class diagram summary. This slide gives a summary of the class diagram section. The class diagram shows the overall structure of the split smart system. It defines the main classes such as user, expense, and group, and it explains how those classes are connected. It also helps us understand data flow and system design. So overall, the class diagram acts like a blueprint for the system because it shows how the major components are structured before the system is actually implemented. Now I will move to the sequence diagram section. A sequence diagram shows how different parts of the system interact over time. It describes the step-by-step communication between users, interface objects, and system components. Each interaction is represented as a message passed between objects in a specific order. This helps us understand how a process begins, how it flows, and how it finishes. In this project, the sequence diagrams are used to represent important operations like adding and approving expenses. They also clearly show the role of boundary, control, and entity classes during execution. So while the class diagram shows structure, the sequence diagram shows the dynamic behavior. This slide shows the scenario of adding an expense step by step. The process starts when the user enters expense details through the Add Expense UI. This is a boundary object that connects the user to the system. Then the Add Expense UI sends the entered data to the expense manager. The expense manager is a control class responsible for processing the request. Next, the expense manager validates the data to ensure all required fields are correct. If the data is valid, it creates a new expense object. This expense object is an entity class that stores the expense details in the system. After that, the system may send notifications to other users using notification service. Finally, the system confirms that the expense has been successfully added. This sequence diagram represents the real scenario of adding an expense. So this diagram clearly shows how boundary, control, and entity objects interact in a specific order. This slide explains the scenario of approving an expense. First, the user submits an expense that requires approval. The system sends this request to the expense manager for validation. The expense manager checks whether the expense details are complete and correct. If everything is valid, the system forwards the expense to another user or group for approval, and the approver reviews the expense and decides whether to approve or reject it. That decision is then sent back to the expense manager, which updates the status of the expense. If approved, the expense is recorded and included in calculations. If rejected, it is marked accordingly. Finally, the system sends a notification to users about the result. And this diagram represents the real approval scenario in the system. All objects used here come directly from the class diagram. This ensures that the sequence diagram matches the class structure and system logic. This slide summarizes the sequence diagram section. The sequence diagram shows how system components interact over time. It explains the step-by-step communication between objects and helps us understand processes like adding and approving expenses. It also clearly shows the role of boundary, control, and entity classes. Overall, the sequence diagram gives a dynamic view of the system and helps explain how tasks are performed in the correct order. Now I will move to the state diagram section. A state diagram shows how an object changes from one state to another during its life cycle. It helps explain the behavior of the system based on events and actions. Each state represents a condition of an object at a particular time, and transitions show how the object moves between states when an action occurs. In this project, I use state diagrams for the expense, user, and group classes. These diagrams help show the dynamic behavior of important system components and make it easier to understand how the system responds in different situations. Now I am explaining the expense state diagram. This diagram shows how an expense moves through different states from creation to completion. At the beginning, the expense starts in the new state when it is first created. After the user submits the expense, it moves to the pending approval state for review. From here, two things can happen. If the expense is approved, it moves to the approved state. If it is rejected, it goes to the rejected state. If an expense is rejected, the user can edit it and submit it again, which moves it back to the pending approval state. Once an expense is approved and payment is recorded, it moves to the paid state. Finally, the process ends when the expense reaches its final state. These transitions are triggered by actions like submit expense, approve expense, reject expense, and record expense. This shows that the state diagram is consistent with the system logic and class structure. This slide shows how a user moves through defined states. A user starts in the new state. After registration using register, the user moves to the registered state. Then the user goes to logged out state. From there, the user can log in using login and move to logged in. If the user logs out using logout, they return to logged out. If there is a problem like multiple failed login attempts, the account moves to locked state using log account. The account can later be recovered using unlock account. And then the process ends at the final state after the account reaches its final condition. These states are controlled by methods defined in the user class. So again, the state diagram is directly connected to the class diagram. This slide shows the life cycle of a group. A group starts in the new state. After create group, it moves to active. In the active state, users can interact with the group. Then the group can send invitations using invite member, moving to invite sent. When users accept using accept invitation, it returns to active. If the group is no longer needed, delete group moves it to closed. And then the process ends at the final state after the group is closed. These transitions are triggered by methods from the group class. So this diagram clearly shows how state diagrams are connected to class methods. This slide summarizes the state diagram section. The state diagram shows how objects change states during their life cycle. They explain transitions based on user actions and system events. They also help us understand system behavior in different situations and clearly show the flow from the start state to the final state. Overall, the state diagrams improve understanding of the system logic and help explain how objects behave over time. These slides combines everything and shows how the system works as a whole. The user interacts with the system through boundary classes like login UI and add expense UI. These inputs are processed by control classes like user manager, group manager, and expense manager. Then the data is stored in entity classes like user, expense, and group. Notifications are handled by notification service. This slide connects all UML diagrams together. Class diagram shows structure, sequence diagram shows interaction, and the state diagram shows behavior. So overall, this slide represents the complete system flow from start to end. In conclusion, the Split Smart system provides an efficient way to manage shared expenses among multiple users. It simplifies expense tracking, splitting, and payment management. The UML diagrams in this project, including the class diagram, sequence diagrams, and state diagrams, clearly represent both the structure and the behavior of the system. The design also supports accuracy, security, and ease of use for users. Overall, SplitSmart can improve group financial management and reduce confusion in shared expenses. This project helped demonstrate how UML models can be used to design a software system in a clear and organized way. Thank you for listening to my presentation. I hope this presentation clearly explained the design of the SplitSmart system and the UML models used in the project. Thanks a lot.